Wait a minute. Oh, hello.
All right, welcome back to Monty's Python Show. In today's video on object-oriented programming, we're going to take a look at private entities, specifically entities that are created inside of class definitions. We're also going to talk about the concept of name mangling, which is a feature in Python that allows us to access private variables or private entities from outside of class definitions. So when we talk about entities that can be private, what are we talking about? Well, there are three main items that can be made private inside of class definitions. The first are class attributes. The second are instance attributes. And the third are regular methods. Those are the three entities that we're referring to inside of class definitions that can be made private using an underscore syntax feature and can be accessed through name mangling. Now there's two levels of privacy in these entities. There's what is called single underscore prefix, and there is double underscore prefix. Take a look at this code example. I've got a number of different attributes and a method defined inside of this class called test. Now you notice the single underscore b class attribute, which is set equal to the value of 88. This is an example of single underscore prefix x, y, and z attributes, x being a class attribute, y and z being instance attributes, and also the method double underscore blub are examples of double underscore prefix. They have double underscores preceding the name of the entity. So let's go back and talk a little bit about these levels of privacy. The single underscore prefix indicates to other developers the intent for a particular entity to not be used outside of the class. The double underscore prefix explicitly makes an entity private and requires name mangling in order to access outside of the class. So let's look back at our code. The single underscore b class attribute equal to 88 is freely accessible outside of the class without name mangling. However, in order to access the class attribute double underscore x, as well as the instance attributes y and z, and the regular method blub, the user would have to use name mangling in the code in order to access those entities. So what is name mangling? Name mangling is a syntax feature that modifies the names of private class entities. It makes it harder to access these entities outside of class definitions. To access private entities, the developer must use name mangling in their syntax. Both class and instance names can be mangled. Class attributes can be mangled in one of two ways, either at the class level or the object level. Take a look at these two examples of name mangling. The first item in the first example, class, is just the name of the class that contains the entity that is private. Then the dot single underscore class double underscore entity name, that is the actual name mangling syntax. Now, since class attributes are accessible both at the class level and at the instance level, you can also access private class attributes through the object by typing object dot and then the name mangled string. Object or instance entities can only be accessed via the object itself. So for example, object dot single underscore class double underscore entity. You'll notice in all these name mangling examples that the actual string of the mangled name is the same in each case. Single underscore, then the name of the class, then the name of the fully private entity. Okay, let's take a look at a few examples of how to use private entities inside of a class definition and how to access them using name mangling. So if you take a look at this very simple class that I have created here called test, we have three different class attributes, A, B, and X. We also have the init method, which creates two instance variables, Y and Z, and we have a method called blub. Now you can see we have different levels of privacy assigned to these different entities inside of the class. For example, the class attribute A is not private at all. In fact, let's go ahead and run this. And down in the console here, I'm going to try and access the variable A using red, which is the name of the object we've created, dot A, and you can see it prints out 99. So that is freely accessible attribute. Let's try accessing the single underscore B variable using red dot single underscore B. And you can see we were able to access the value of that attribute 88, no problem. So the single underscore B, as we talked about in the slideshow at the beginning, is just to indicate to developers that that particular attribute is only meant to be used inside of the class definition and is not intended to be used outside of the class, but it nonetheless does not have the level of the double underscore prefix privacy, and so it's fully accessible still. Now let's take a look at the attribute double underscore x. So red dot double underscore x. Okay, so you see now we've gotten an attribute error. Test object has no attribute double underscore x. But we clearly see here that we do have an attribute double underscore x. The problem is that Python has changed the name of that variable to add name mangling syntax to the name. And so in order to access that attribute, we have to take the extra step of including the name mangling as we refer to that object. So for example, let's access it like this, red dot. Now let's use our name mangling. So remember, the name mangling is a single underscore followed by the class name. In this case, the class is called test. Then the name of the double underscore variable. So double underscore x. Now I was able to access the value of 1 from that private variable. So that worked fine. And the other way we could access that, since it's a class attribute, we could have also accessed it this way. Test dot single underscore test double underscore x. And you can see that also accesses it. So remember that just like a normal attribute, class attribute, you can access those either from the class name or from an actual object name. Now let's take a look down below at the private variables we've created down here. We've got y and z. So why is it that this code down here, for example, self dot double underscore z, is defined as double underscore y minus double underscore x? Why doesn't that raise an attribute error? Well, it's because double underscore prefix attributes that are defined inside of your class can be used inside of the class definition without name mangling. It's only from outside the class that you have to use the name mangling in order to access those variables. So let's take a look at, for example, the instance variable double underscore z. So let's type in our instance, which is called red dot double underscore z. Let's see if we can access that instance attribute. No, once again, we got an attribute error because that is a fully private attribute and we need to use name mangling. So once again, to access it, it's red, the name of our object, dot, single underscore test, that's the name of our class, and then the name of our entity, double underscore z. Now you can see we can access that variable, which is equal to 7, which is just the value of y minus the value of x, which is 8 minus 1. Because 8 was passed in as an argument, that's what set the value of y here. All right, let's take a look at the method that we've created, the regular method blub. And just like the attributes, you cannot access it because it is a double underscore preceding it. So it is a double underscore prefix level of security, which means you need to use name mangling. So for example, if I try to do red and invoke the blub method, I get an attribute error. However, if I type in red dot underscore test double underscore blub, that invoked the method and printed the message that is defined inside of that method definition. You should assume there will be at least one question on the PCAP exam trying to access a fully private attribute or method without proper name mangling, or questions about properly written syntax of name mangling. There'll be at least one question on the PCAP exam. Hopefully this helps you understand it better. Set the value of y here. All right, let's take a look at the method that we've created, the regular method blub. And just like the attributes, you cannot access it because it is a double underscore preceding it. So it is a double underscore prefix level of security, which means you need to use name mangling. So for example, if I try to do red and invoke the blub method, I get an attribute error. However, if I type in red dot underscore test double underscore blub, that invoked the method and printed the message that is defined inside of that method definition. So hopefully this clears up for you and helps you understand the difference between single prefix and double prefix privacy in class entities, and how to use name mangling to access private entities. And you should assume there will be at least one question on the PCAP exam trying to access a fully private attribute or method without proper name mangling, or questions about properly written syntax of name mangling. There'll be at least one question on the PCAP exam. Hopefully this helps you understand it better.